Good morning. I'm Neil Holt. I'm the director of the Space Dynamics Laboratory. We welcome you and are thrilled that you could make it to this once-in-a-lifetime event. If you want a stressful job, go into IT and have a NASA downlink and things go wrong right before. At this time, we ask you to please turn off your cell phones if you have one. Senator Orrin Hatch was disappointed that he could not attend today. His Senate duties prevented him from traveling here in time to make this event this morning. Senator Hatch did send a short video message, which we will watch and listen to in just a few minutes. Several members of Senator Hatch's staff are here with us, and we're pleased to have them participate with us today. Thanks, Matt, Rachel, and Nate. Senator Hatch has been a strong supporter of the space industry and our nation's efforts in space exploration. SDL remains grateful to have such a stalwart advocate represent the great state of Utah in Washington, D.C. Senator Hatch has asked former astronaut Charlie Precourt to share a few remarks today and to make the call to the International Space Station for us today. Charlie Precourt is the Vice President and General Manager of Propulsion Systems at Orbital ATK, and as I mentioned, a former astronaut. We also have many distinguished visitors in attendance with us today. H. Scott Hinton, President of the USU Research Foundation. I'm not sure if we have either of the mayors with us today. We invited Mayor Craig Peterson, Mayor of Logan, and Mayor Berenson, Mayor of North Logan. We have Teresa McKnight, Director of USTAR Incubation Enterprises and the Utah Science, Technology, and Research Initiative. We have Tammy Getz, Director of the Utah STEM Action Center. Dr. Beth Foley, Dean of the Emma Eccles Jones College of Education and Human Services at USU. Dr. Mark McClellan, Vice President for Research and Dean of the School of Graduate Studies at USU. Dr. Mara Hagan, Dean of the College of Science at USU. Eric Packingham, Director of the USU STARS Gear Up Program 1. James Doward, Director of USU STARS Gear Up Program 2. Nina Galatly, Advisor at USU College of Engineering. Perry Oakes, a Senior Manager at Government Affairs for Lockheed Martin. Jason Stanger, Executive Director and Principal of Intech Collegiate High School. And Dallin Graham, Director of Cash Makers 4-H STEM Club. I want to extend my appreciation to our partners, USU STARS Gear Up, Intech Collegiate High School, and the Cash Makers 4-H Club, and their efforts to promote space exploration to help educate, engage, and inspire students. We're also excited to have so many of you students here in attendance with us today from throughout Utah, and understand that some of you have traveled many hours to be here. Thank you for making that trip to be here with us today. Now it's my pleasure to introduce Charlie Precourt to you. Charlie is the Vice President and General Manager of the Propulsion Systems for Orbital ATK's Flight Systems Group. He's responsible for key programs including Solid Rocket Booster for NASA's Space Launch System, Trident II, and Minuteman III strategic missile product lines, the Ground-Based Mid-Course Defense Program, and the commercial rocket motors and products. Precourt joined Orbital ATK in March 2005 as Vice President over Strategic and Business Development, and was responsible for business market analysis, developing new customers and market opportunities, and matching Orbital ATK's capabilities and synergies with customer requirements. Before coming to Orbital ATK, Precourt had a distinguished 15-year career with NASA. Qualified as a space shuttle astronaut in 1991, he's a veteran of 4 space flights, including 2 as mission commander, and has logged more than 932 hours in space. In addition to his duties as an astronaut, Precourt also held several management and technical positions with NASA, including Deputy Program Manager for the International Space Station, Chief of the Astronaut Corps, and Director of Operations for NASA at the Gagarin Cosmonaut Training Center in Star City, Russia. Precourt also served for 23 years with the U.S. Air Force, retiring as Colonel in March 2000. He is a graduate of the U.S. Air Force Test Pilot School at Edwards Air Force Base and flew as a test pilot on the F-15E development program. Precourt was an F-15 pilot, instructor, flight commander in Europe, and an instructor pilot at both Reese and Edwards Air Force bases. A native of Hudson, Massachusetts, Precourt received a bachelor's degree in aeronautical engineering from the U.S. Air Force Academy, a master's degree in engineering management from Golden State University, and a master's in national security affairs and strategic studies from the U.S. Naval War College. He also attended the French Air Force Academy in 1976 as part of an exchange program. He is fluent in both Russian and French. Please join me in welcoming Charlie Precourt.
Thank you, Neil. Well, are you all ready for some fun? The last time I did one of these, I was on the other side of it in space, so I'm going to be a little bit jealous, but I'm really, really thrilled to be here to join you for this. And I'm really particularly thrilled on behalf of Senator Hatch, who obviously was very instrumental in making this happen. More than you know, Senator Hatch has been a stalwart advocate for all that NASA does, and in particular that has supported a lot of our workforce here in Utah that supports NASA. Today we at Orbital ATK are building the next big rocket that will take astronauts back to the moon and out to Mars. And it'll be in your generation that we're doing that. So we're building a system today to hand over to you to operate and be the first to get to Mars. So this is a really thrilling day to make that connection, because you are, in fact, our future workforce. And Senator Hatch would be the first to say that science, technology, engineering, and math, STEM-focused activities like this are very, very important to connect you as the students to the future of the country and future technologies that you can be a part of. So on behalf of Senator Hatch, I'm really thrilled to be here, and he sends his regrets. You know, the work in Washington never stops. But I just want to emphasize how important he has been to our space program and to our community here in Utah. And to Matt Jensen and the staff that works for him, thanks for all you've done to make this happen. They have really been the leaders in Washington for all that we're doing at NASA, and so it's really thrilling. As I mentioned, the last time I was a part of this, I was on the other side of the communication talking to students from in orbit on the space station and on the space shuttle. I even got to talk to students from my hometown one time. This is a lot of fun. Look forward to hearing the questions and the answers from the astronauts. So thanks for letting me be a part of this, and I'm delighted to be here, and I hope that you see as students an avenue to your own future careers in being exposed to this event today, because that's what it's all about. Senator Hatch sends his regrets at not being able to attend, but he did have a video he'd like to share with us, and so I'd like to go ahead and introduce that now and let him speak directly to you that way.
Good morning, and thank you for allowing me to briefly speak to you today. First, I would like to apologize for not being with you in person at today's great event. I regret that my Senate responsibilities will have kept me here in Washington. I'm thrilled that we were successful in working with the Space Dynamics Lab at Utah State University and with NASA to secure the downlink, giving us this unique and exciting opportunity to speak with astronauts on the International Space Station. It's exciting. Today's event will be an incredible opportunity for all those watching to capture a greater sense of and appreciation for our space program, and hopefully to understand better the connection between education and practical application. I'd like to briefly speak to the thousands of students across the state who will be watching this special event. I'd encourage all of you to use this event today to learn and grow and develop greater curiosity in your studies. STEM, or science, technology, engineering, and math, are so important. And there are a lot of exciting careers and opportunities for you all to learn about. Sometimes it might seem like those subjects are a little bit boring. I confess that they were not my favorite subjects in school when I was there. But pay close attention to these two inspiring astronauts today. Jack Fisher is a character. You can follow him on Twitter to see how he handles his time on the space station. Peggy Whitson is a tremendous role model. She grew up in a farm in Iowa, took a strong interest in science, and is now the first female commander of the International Space Station. She spent more continuous time in space than anyone else from our country, man or woman, and she's beating her own record every day. Careers in STEM provide incredible opportunities for both men and women, and I believe Utah students can be leaders as we move ahead, diving even further into space. Again, I apologize for not being with you in person, but I want to thank the astronauts, the people working at Space Dynamics Lab and NASA on this call, and all of the students, teachers, and parents who are participating in Logan and classrooms all over the state. Thank you, and God bless you all.
Now, for the students, you heard what he said, right? Pay attention in science and math because you can actually use it. And my colleagues on Space Station today use it all the time. And I'll tell you just a couple of things about Peggy and Jack. Peggy Whitson was a scientist at NASA before we selected her as an astronaut, and she worked under me when I was the chief astronaut. She is a wonderful person and a very, very talented woman in the astronaut corps, and as the senator mentioned, the first woman to command the space station and has more time in space than any other American. That's an incredible accomplishment for someone who came from a farm in Iowa. So it doesn't matter where you come from. I personally grew up in a very small hometown in Massachusetts of only 16,000 people and never had any dream that I'd be an astronaut. It actually happened. So connect what you're doing in school to the future potential of your career, and it's amazing what it can do for you. So look forward to talking to both of the astronauts with you today, and I'll turn this back over to Neil. Thank you very much for having me.
Thank you, Charlie. And now I'd like to introduce Dr. Jed Hancock. Jed is Civil Space Division Director here at Space Dynamics Laboratory and is responsible for all of our NASA missions. These missions support NASA's vision to reveal the unknown for the benefit of humankind. Jed has worked on many high-profile programs for NASA, such as the OSIRIS-REx and ICON missions. OSIRIS-REx launched last year and is on its way to an asteroid to collect samples and bring them back to Earth for scientists to study. The ICON mission is scheduled to launch later this year and is designed to further study the ionosphere and determine its effects on our technology and communication systems. Recently, Jed has been working with the Jet Propulsion Laboratory on a project called NEOCAM, a telescope proposal to further NASA's efforts to find and define asteroids that are relatively close to the Earth. Jed received an undergraduate degree and a Master's of Science in Electrical Engineering from Utah State University. He earned an additional Master's of Science degree in Optical Sciences and received a PhD from the University of Arizona, where he was valedictorian in 2012. Please join me in welcoming Jed Hancock.
Thank you, Neil. I am excited to be here with you today, honored to be a part of Utah State University in the great Space Dynamics Lab, and more excited to tell you a little bit about a career in space. I love working in space for a lot of reasons, mostly because the things we do in space, they might seem like science fiction, and occasionally you kind of have to pinch yourself to realize that you're really doing what you're doing, and then you realize that it's real life. It's not science fiction. That we have astronauts right now in a house we call the ISS, as big as about a 6-bedroom house, flying at about 17,000 miles an hour above our heads. And just in the time frame of this phone call, in the 20 minutes we talk, they will travel about 6,000 miles. They'll go all the way across the distance of the United States just in the 20 minutes we talk to them. It's really incredible what happens in space. So I want to ask a question. Has anybody seen a meteor shower? Okay. Would you stand up? What do you see when you see that meteor shower?
Lots of shooting stars.
Lots of shooting stars. They shine so bright, they'll light up the entire sky, don't they? Those shooting stars are actually space rocks. Scientists tell us that our Earth lives in a shooting gallery of asteroids, comets, and meteors. And those meteor showers you see, all those falling stars, are rocks entering the Earth atmosphere at such a speed, they heat up so bright they light up the night sky. We know that we have millions, 8 to 10 millions of asteroids and comets and meteors circling the sun. These pieces of matter, they were there when our solar system was formed. And they are unchanged clues about how life began, how our solar system itself was formed. Here at SDL, we got to work on a really cool project called OSIRIS-REx. The name stands for something, but it kind of sounds like a dinosaur. This is a robotic spacecraft that right now is hurling through space at incredible speeds, chasing down an asteroid that's about the size of a football stadium. And this asteroid has minerals that holds clues about how our life began. This spacecraft that we helped work on, we built cameras that will help find the asteroid, guide the spacecraft as it comes up close, document as we touch down on this asteroid with our spacecraft. We'll collect a sample, and we'll bring that sample all the way back to Earth, and it will descend right here in Utah over Tooele in 2023. Most of you guys will be graduated from high school then. But it's going to be a great experience, a great event. And those scientists, when they get that material, they'll think they've won the lottery. They'll be studying that for years. It will hold clues about how life really began in our solar system. Now, being on a space project, we have a lot of players on our team, not just engineers or scientists. Here at SDL, we have technicians, technical writers, accountants, cost analysts, media representatives, IT personnel, electrical engineers, mechanical engineers, software engineers. We have a lot of players on our team, and every one of them are essential and have a successful space enterprise. I couldn't be more proud to be a part of SDL. The International Space Station that we'll talk to today, we have done many experiments that are on that station. For example, there's a device outside the space station that helps assess what the electrical charge is around the space station, so astronauts know it's safe to go on a spacewalk. Next year, we're going to launch a tank that we built, a special tank that we built at SDL that will prove you can refuel satellites in orbit, kind of like 7-Eleven stations or Mavericks where you go get gas. We'll launch these tanks into orbit and be able to refuel our satellites in the future. And that's the kind of technology we work on at SDL. I got a question for you students. Has anybody ever understood how a satellite actually stays in orbit? Let's see. Would you stand up loud for us?
It has something to do with the gravity and its mass compared to Earth's mass and going around the Earth.
Perfect. About 400 years ago, Kepler, Newton, they came up with this idea, right? Called gravity. And just imagine yourself climbing to a really high mountain, way past the clouds. And if you had a cannonball and you dropped it, gravity would force it to fall back to Earth. But if you shot that cannonball from the top of that mountain really fast, like 17,000 miles an hour, which is how fast Charlie got shot off on the space shuttle. I can't imagine what that must have felt like. That cannonball would keep falling towards Earth, but it would be going so fast that as it fell, it would travel, and it would just keep rotating around the Earth. And that's how satellites get launched into low Earth orbit. Rockets, like the kind that they build at ATK, just miles from here, they launch our satellites at incredible speeds. Incredible speeds. Another cool thing about working in space. Here at Space Dynamics Lab, we get to travel the entire country, the entire world, working with different scientists, people from different nationalities. And space is truly becoming something that the whole world appreciates. Every time you turn on a TV, you can almost count that those signals got to your house by first going all the way out to a satellite in orbit and then coming back to your house. At SDL, we're launching a rocket this year that's going to be looking at the close boundary between space and Earth. When you fly in an airplane and you get up there, you're still in the Earth because those wings are still flying right above the Earth's surface. But if you go just a little bit higher, like a mile higher from when you're flying on an airplane, pretty soon you're in space, you're on that boundary. And we're launching a satellite that's going to measure exactly what that boundary is and how the transmissions from our satellites go between Earth and up to space, and help scientists better understand what the weather's like in outer space. Now, before we call these two brave astronauts, I'd like to tell you just a little bit more about them. Dr. Peggy Whitson is the current commander of the ISS. She's a biochemist. She holds some world records and firsts. Actually, they're out of this world records, if you know what I mean. She was the first woman commander of the ISS. At 57 years old, she now holds the records for the oldest woman spacewalker and the record for the most total spacewalks by a woman. Last month, she broke the record for the most days spent in space by any astronaut. After high school, she received a Bachelor of Science degree in biology and chemistry from Iowa Wesleyan College in 1981. She then went on to earn her doctorate degree in biochemistry from Rice University in 1985. Following completion of her graduate work, she continued working at Rice as a Robert A. Welch postdoctoral fellow until October of 1986. Jack Fisher, his call name is Two Fish, he was selected in July of 2009 as a member of the 20th astronaut class. He completed astronaut training in 2011. Prior to becoming an astronaut, the Colorado native graduated from the U.S. Air Force Academy, Colorado in 1996 with a Bachelor of Science in Astronautical Engineering. He went on to receive a Master of Science in Aeronautics and Astronautics from the Massachusetts Institute of Technology in 1998. Colonel Fisher has been working in the Capsule Communicator, Soyuz International Space Station Operations, International Space Station Integration and Exploration Branch of the Astronaut Office. Now, we're just a couple of minutes from making this phone call. So I want to tell you a couple of things. First, space is really quiet. So I appreciate how quiet you're being. We need to be this quiet during the call. After we ask a question, it will take a little bit of time for the astronauts to respond, okay? Just that little delay when the question's asked getting up to the space station, and then we'll be patient for their response. So we can hear and see the astronauts, but they can only hear us. So NASA's recording the event, and they'll send the astronauts the video of all of you students when it comes back. Charlie, I'd like to invite you to come up to the stage with me as we prepare to make this phone call. Is that all right? We'll be seated over here. And our students, when the time comes, they'll be standing over here on the ramp and walking up carefully, and I'll be handing them the microphone. While we have this 1 minute, I'd like to ask Charlie just to share one thought with us. Charlie, what did it feel like to be flying above the Earth at 17,000 miles an hour?
Well, there are an awful lot of feelings. It's an amazing place when you can be outside the Earth looking back. But when you mentioned the, shooting stars, there was an evening where I was in the cockpit of the shuttle looking out my front window with the Earth below, and I saw a shooting star go in underneath me. Didn't see it go by, but I saw it going in underneath me, and I thought, my, I'm glad that didn't come any closer than it did. It's just an amazing sight to see the Earth. It looks like it's glowing from inside. It's such a phenomenal sight to see black all around it. Even in the bright of sunlight, the sky is completely black because sun only lights those things that it hits. And when there's the emptiness of space, it stays black. So the Earth looks like it's glowing from inside. It's really incredible.
Thank you, Charlie. We'll have to take your word for it. But there are beautiful images you can get on NASA's website. Okay, we're just seconds away from the phone call. So Charlie, would you help initiate this call?
Sure will.
Station, this is Houston. Are you ready for the event?
Yes, we're ready for the event.
Space Dynamics Laboratory, this is Mission Control Houston. Please call station for a voice check.
Station, Peggy and Jack, this is Charlie Precourt. Are you hearing me okay?
We're hearing you great, Charlie. It's good to hear your voice.
I am really jealous not to be on that side of the phone call, but it's really great. We got a room full of very excited people and students to talk to you. So I'm going to hand the mic over to them.
Okay, excellent.
Thank you. We'll dive right into our questions.
What did you have to do to prepare yourself and your body and your mind to be an astronaut?
Well, to be an astronaut, you do need to be physically fit. We are expected to do spacewalks, which does require some physical strength to some degree, and obviously we have to be fit in order just to do the job. But I think probably the most important qualification for being an astronaut is to have studied in some field in math, science, or engineering. And we have astronauts in all of those fields, all different science fields and engineering fields and aerospace fields, and pilots like Jack.
So it being the International Space Station, as part of your astronaut training, do you have to learn different languages?
Yeah, and absolutely you do. At a minimum, we have to know English and Russian on the space station. But we also train in Japan, in Germany, in Canada. We go all over the world for our training. And more importantly than just the language is you have to understand the culture so that we can work better as a team, both with our ground team and our team here on the space station. The world is getting smaller, and you have to be more worldly. You have to work on your language skills in order to find your place in it.
What are the psychological effects of being in such a confined space for such a long amount of time?
Well, actually, the space isn't all that confining. We have 16 different modules, and each of them is about the size of a school bus. So there's a lot of space in here, and with only, right now we only have 5 crew members on board, so we spend a lot of time working every day, and we might not run into anybody until lunchtime when we join up together to eat lunch.
What is the best food in space?
Yes. Actually, my answer would be everything because it floats. So I'm going to demonstrate. I like coffee balls because I like coffee, but I figured you guys would think that tropical punch is kind of cool because it's red and kind of awesome. Here we go. So you can make a big ball because of surface tension of the water, or
Tricks by Jack.
What kind of trash does the ISS produce, and how much of it will be burned using the Cygnus spacecraft?
Actually, we do generate quite a bit of trash from all the different scientific investigations, and we do hardware upgrades all over the station. So anything that gets shipped up here has to be packed in foam and padded to handle the launch loads. So there's all kinds of trash that gets generated. And we do luckily have trash trucks like Cygnus and Progress and HTV that will take our waste away, and it does burn up in the atmosphere. But again, these are small school bus sized modules that carry away quite a bit of trash. So luckily for us.
If you could give your 17-year-old self one piece of advice, what would it be?
well, I'd give the advice my dad gave to me when I was 18, and that was, I dare you to dream. That has 2 important parts. First off, the dream part. Only you can find what it is that's your passion, what it is that's your dream, the thing that makes you just lights a fire in your soul. You have to define that for yourself. And then the second part I dare you to dream is that no one is going to give that to you. Not everybody gets a trophy in life. If you don't work really hard at it, really hard at your passion, it will never happen. I can guarantee it. So those are the two pieces that you need to find. You need to define that dream. You need to find your passion, and you need to follow it with all you got.
What do you do for fun?
Actually, probably the most fun thing is looking out the window. But I tell you what, just every day being here in space, floating, figuring out, you know, how many circles you can make crossing the laboratory module, or, you know, coming up with these fun games that you can't do or play on Earth because we have lack of gravity here, which is why it makes the science so interesting as well. But it absolutely is a fantastic environment to work in.
Do you ever play any instruments aboard the space station?
Why, that is a fantastic question. I don't, but we just so happen to have someone who does. He may be floating by now. He speaks lots of languages, plays lots of instruments. He's not good for our self-confidence as people, but kind of an amazing dude. That is our Frenchman, Thomas Pesquet.
What is the adjustment process to life in space?
Actually, the biggest adjustment is that lack of microgravity I mentioned before. Learning how to work with tools that will float away if you don't tape them down or Velcro them down or have them contained in a bag of some kind or another. That's probably the biggest adjustment. But physiologically, our bodies are adjusting also without gravity pulling on our fluids. We have a fluid shift that occurs initially when we get up here. So that's also occurring as well.
Does time seem to pass slower, quicker, or not at all while in space?
Oh my gosh, so much faster. You know the adage, time flies when you're having fun? I mean, we have fun all day. We're doing science, we're fixing stuff, we're looking out the window, we're taking pictures. Everything that we do is just fun. So I can't believe it's Friday afternoon of another week. It goes way faster.
What if you run out of materials before you can get more?
Well, it would be a little slow if we didn't have as much to do, but I think we could probably entertain ourselves for a few days. No, and our resupply is very important for what we're doing now because we're doing so many different types of research experiments that we do need some resupplies. But we have a lot of experiments that can run without too many resupplies, and we would continue working on those, I'm sure.
My name is Amy Iverson. I'm asking the question for Thomas. What are some of the current experiments that you are doing, and what can be potentially learned from them?
And it's a hard question to answer. Just in my time on this station, and Peggy's many more, there's over 300 experiments that'll take place. We're doing everything from human physiology, Peggy and Tomas spent the last couple weeks working on a bone investigation study. We can grow perfect crystals, so we can look at virology and immunology. We have an experiment on board that is looking at new ways to create lightweight and stronger alloys. It's just the expanse of scientific experiments that are on the space station right now is absolutely mind-boggling. So to say which ones will have the biggest impact, I have no idea. I do know that this place and what goes on here is changing humanity for the better.
What's your favorite thing about space?
Being in space. Just being able to float, relax. Every orientation that you're in feels the same. It's an amazing experience, and just being here is what makes it special.
What are your jobs and responsibilities on the space station?
So that's one of the things that makes it so interesting, is because every day is a bit different. We may be doing something one day, and then Peggy does it. Peggy does it the next day, and Tomas does it the day after that. There's so many different things that we're doing because there's so many experiments. Our big jobs are maintaining the station, and then the science. We also have to, clean it. Housekeeping is one of the things that we do. But for the most part, we're jack of all trades, master of none. And the big thing is that Peggy is the commander. That role is most important in emergencies. Other than that, we're kind of a team all the time, just getting the job done every day.
How does zero gravity affect your body, and do you get stomach aches?
Zero gravity actually does have a lot of effects on your body because you don't have gravity pulling on your body. The first thing I talked about was the fluid shifts. That may have some impacts that we've seen, some changes in eyes in the astronauts. We've also seen without significant exercise, we'll have bone loss and muscle loss. So we're studying those things, figuring out what it takes, what's the minimum exercise amount required to keep us healthy, because when we do those future exploration missions, maybe one of you will be participating, and we'll have it all worked out and figured out exactly what the minimum is required to keep you healthy and safe. And you might think with the lack of gravity, you might have a stomach ache, and eating. I don't really feel any different sensations while I'm eating, so it's great. Still enjoy eating too.
What are the procedures you follow in the event of an emergency?
Yeah, that's a great question. We have a lot of different emergencies on the station that we train for, but the three big ones are fire, rapid depressurization if there's like a hole in the station, and then a toxic atmosphere, most notably ammonia, because our cooling system outside uses ammonia to cool things down, and it's not very good for you. So we train those until we have them basically memorized, because we have to have a memorized response and be able to react quickly. That's where, I mentioned that it's kind of we're all working together. Obviously, that's true, but during an emergency, you need to have a boss, and that's our resident space ninja, Peggy, telling us what we need to do and where we need to go so that we can all get home safely.
What do you do during your free time in space?
Actually, looking out the window never gets boring because we get to see the Earth. We're going around the Earth 16 times in a day, traveling at 17,500 miles an hour. We see a sunrise and a sunset about every 45 minutes. So it's always amazing to be able to look out the window and see something new. The light angle will be different. We'll be in a different inclination. Things are just always interesting looking out the window. But of course, we're up here with just 4 other people right now. And so we can talk to our family and friends on an internet protocol phone when we have the specific satellite capability available. So it doesn't really feel that we're too separated from them, and it's nice to stay in touch with them via email as well. So that's most of our entertainment, and then figuring out astronaut tricks.
What does it feel like knowing that you're one of so few people that has actually been in space?
Well, honestly, that it's very, very humbling to be a part of that group. But it humbles me. It also inspires me to make that list a lot bigger. And I think that your generation, all of you students that are there, if you're engaging in those science and technology, engineering, math type of pursuits, you're going to be the fuel for our engine that takes us into the next generation. So I really feel that space exploration is about to really, really take off. We're building the infrastructure with commercial endeavors, as well as the largest rocket we've ever built. So Space Launch System is going to be bigger than anything that's ever flown. And all of this is coming together with a commercial enterprise, both for commercial spaceflight and cargo to the station. And then you have this wonderful laboratory. So you are the generation that's going to take us into the heavens for good. And I'm really excited for that list to get huge really soon. And hopefully your names will be on it.
Is the ISS able to be driven?
Actually, that's a really great question. The ISS, the truss that holds our solar arrays is the length of a football field long. So it does take quite a bit of momentum, in our case, to drive the ISS. And we have these control moment gyros that are spinning at 6,000 RPMs. And we can change the momentum to move the station, even something as large as this football field-sized structure that we have. And if we need to increase or decrease our altitude, for instance, for debris avoidance, if we see something ahead that we need to avoid debris, we can increase or decrease our altitude with the thrusters in the aft end of the Russian segment, so we can thrust up or down. And we also can change our altitude to meet visiting vehicles, to optimize for them as well. So yes, it is drivable, but not maybe in the sense that you might think.
What weird stuff have you seen in space?
Well, pretty much everything's weird. Don't point at me. That's not nice. Everything's weird. You get to see things floating and spinning, and when you eat your food, I was eating pudding last night, and I cut a little hole in the packet and I squirted the whole thing onto a spoon, and it was this gelatinous jello mountain of yummy, and I mean, that's just weird, but it's cool. There's just so much cool up here. Everything is weird. Sitting on the ceiling, how's that for weird? But the thing about it is there's so many different opportunities for you to stretch your mind and redefine reality and just grow as a human that I absolutely love this place.
Thank you, Jack and Peggy. We just have a couple of minutes left, so we have 2 more students with some questions.
What classes do you have to study in college to become an astronaut?
Well, it's kind of like Jack said, any field, math, science, and engineering, but you really need to pursue something that means something to you, that gives you the passion to want to study it, to want to be an expert, and that really drives you. And that's what you need to pick. So there's nothing specific other than being in a math, science, engineering, technology kind of field.
Do you have internet in space? And if so, do you spend much time on computers or on phones surfing the web?
Well, I'm kind of a computer geek on the ground, but up here, not so much. Our internet, we have the capability to do internet, but I'm going to use a word some of you probably don't even know what it means, dial-up. It's really slow, like back in the old days where we had a modem and it would, speed was measured in baud. Do you guys know what baud is? It's really slow. So we don't do much with it, and honestly, it would be a waste of time in space to be spending a whole lot of time on the internet up here. We have some people that can help us and post things so that we can share what we're experiencing with those on the ground, but for the most part, we don't spend a lot of time on it.
This has been an incredible experience. We are so thankful that you would join us today, and I'm going to turn this over to your friend Charlie to say goodbye.
Jack and Peggy, that was awesome. And Jack, you alluded to what these students can be in their future, and really appreciate the connectivity there from space station on into the deep space journey that we're on. Thank you so much. And these are, in fact, our future scientists, engineers, and our workforce in the future of space. And you did great. We really appreciate the opportunity.
Well, thanks a lot, sir. And I don't know if you remember, but you were the guest speaker at my test pilot school graduation, and you and Peggy and you guys inspired me and others. And I think it's just a self-licking ice cream cone of inspiration. We need to keep this going and continue so this next generation can be even better than we were.
Indeed. Like I said, I'm jealous, especially that I'm not the one sitting on the ceiling up there today. Keep up the great work, both of you.
Thank you to all participants and guests from Space Dynamics Laboratory. Station, we are now resuming operational audio communications.
How about one more hand for our astronauts? I'd like to thank Charlie and our other distinguished guests, but most of all, for all of you kids for being here. And hope you have seen and felt today in this discussion that your future is truly out of this world. And we're thankful that you're here. And I hope to see all of you here as Utah State Aggies. Now, one of the best parts of being an Aggie is we have some Aggie ice cream on the back for you. And after you've had your ice cream, please return quickly to your seats after you've enjoyed your ice cream for a minute or two, and then we'll start some other really cool space presentations.